Welcome back to part 6 on Intro to Angles. In this video, we're going to look at some different setups or contextualized problems for linear and angular speed. So the first question we have is we need to look at the minute hand of a clock, which is 10.2 centimeters long. This clock hand, think of it as rotating around the clock. So if it's a minute hand, it takes 1 minute to go all the way around, and I'll go clockwise because it's a clock. So its radius R is 10.2 centimeters, and we need to find the linear speed first. So remember that linear speed can be found by using the formula V equals S over T. And remember that S equals R theta over T, where theta is in radians. So I'm just going to substitute the radius as 10.2 centimeters times theta, which is the angle it rotates through, and we know that it rotates 1 time around the clock face in 1 minute. So we'll say 2 pi, and the time is 1 minute. So if I wanted to write this and leave pi as is, it would be 20.4 times pi per minute. If we wanted to actually find the distance in meters, in centimeters, because this was in 10.2 centimeters, we could take pi and multiply it to 20.4 to get the actual centimeters traveled. Which is 64.1. 64.1 centimeters per minute is the linear speed. So that's how far the tip of the clock hand will travel in 1 minute. Now let's look at angular speed. Remember that angular speed can be defined by omega equals theta over t. This is just the angle that it moves through with respect to time. So our angle we know is 2 pi, and our time is 1 minute. So its angular speed is 2 pi per minute. Let's take a look at a car that is moving at 50 miles per hour. It has tires with a diameter of 2.5 feet. If we want to find the number of revolutions per minute the tires are rotating, we'll have to do some conversions. So the first thing we need to do is convert 50 miles per hour to feet per minute. So the first thing I'll do is use conversion factors. 50 miles per 1 hour. I need to convert the time or hours to minutes. I know that 1 hour has 60 minutes. And I also know that 1 mile, I want to get rid of miles, so I'll put miles in the denominator. I know that 1 mile is 5,280 feet. So this will give me a new measurement for the linear speed. So remember, linear speed is V. So we're finding V right now. If I multiply 50 times 5,280 and then divide by 60, I get 4,400 feet per minute. Now, if I want to find the number of revolutions per minute the tires are rotating, I need to figure out what 1 revolution is and then divide by that. So I know that a revolution of this tire will be the circumference. And that's just going to be 2 pi times the radius, which is 1.25. So I can find the number of rotations or revolutions per minute by taking the linear speed right here and dividing it by the circumference of the tire. This will give me 4,400 feet per minute divided by 2 pi times 1.25 feet. This gives me, once I calculate it out, right at approximately 560.2 revolutions per minute, or RPM. Now let's find the angular speed of the tires in radians per minute. Now remember, angular speed is just how fast the angle is changing. This is not the linear speed where we're looking at how fast you have to move to keep up with that rotation of the angle. So for angular speed, we know that that's omega equals theta over t. And I happen to know that v is equal to s over t, where s is your arc length, or r theta over t. And I should note here that r theta over t can be broken up into pieces, where theta over t is omega. So I can rewrite the theta over t as omega, and I'll get v is equal to r omega. And I happen to know what the linear speed is because I calculated it up here. So my linear speed is 4,400 feet per minute. And so I can find r and omega simply by solving for omega. That means I'll have to divide both sides by r, and I know what r is. So if I calculate omega, it's going to be 4,400 feet per minute all divided by the radius. And I know what the radius of the tires is. It's 1.25 feet. So my final angular speed is going to be 3,520 radians or radiuses per minute. I would try some of the examples in your textbook, maybe watch a few more videos on this, because this is really a new concept for many of you, and if you're struggling with this, it's going to be very helpful to work through a few more examples.